prospective students, parents, family, and friends. Hello, my name is David Schreiber, and I'm a professor and chair of biomedical engineering at Rutgers. I want to thank you for viewing this presentation to learn about our program. Of course, I'd much prefer to deliver it to you live and in person, but I hope that you find the presentation informative and that you learn why we believe Rutgers BME is a great place for your education and training. At the end of the presentation, I'll provide contact information for any unanswered questions or comments. I'd like to start by describing to you how I define biomedical engineering. I see biomedical engineering as the discipline that operates at the intersection of engineering, biology, and medicine. It is, as its name describes, inherently interdisciplinary, which makes sense if you think about it. Let's say I'm trying to grow a tissue-engineered artery for bypass replacement surgery. In addition to knowing the basic mechanics, transport, and material requirements, I need to understand the underlying medical problems, the biology that cause those problems, and how things will change and adapt once I introduce the graft. At this intersection, biomedical engineers use engineering principles to study, understand, and make new discoveries about how our bodies work at multiple scales, from proteins to cells to tissues to the whole body, and what happens when things stop working. Biomedical engineers also apply this knowledge to design and develop new technology to address these problems and directly improve human health and welfare. These problems are incredibly complex, which makes the work that biomedical engineers do and the training they need very challenging, but also very exciting. So now that I've described what a biomedical engineer does, why should you choose Rutgers BME? Well, we have one of the largest undergraduate programs in the nation, and we're one of the top 15 best value programs. We're a state school with state tuition for in-state students and reasonably priced tuition for out-of-state students, with a wide variety of programs to offer for all interests. We also have beautiful state-of-the-art research and training facilities, a new building that opened in 2007. We have a very collaborative community of faculty and students, and that includes the clinicians and medical students at Robert Wood Johnson Medical School. And of course, New Jersey is a great place for biomedical engineering. We're located in the Cure Corridor with over 300 biotechnology companies in the state. 17 of the 20 largest pharmaceutical, medical technology, and diagnostic companies are located near Rutgers. So that's a little bit about why I think biomedical engineering is great and why Rutgers is a great place to study biomedical engineering. But I was interested to know what our students think. So I've polled them, and overwhelmingly, our students choose biomedical engineering because they want to be engineers who help people. They want to do this by researching and making new cutting-edge biomedical discoveries to understand how we work and what goes wrong when things don't work well, to develop novel, life-changing biomedical technology to help human health and welfare, and to practice medicine and directly see and treat patients. How does Rutgers BME train its students to meet these goals of researching and making new biomedical discoveries, developing novel, life-changing biomedical technology, and preparing for potential careers in medicine and health professions? We accomplish this through rigorous academic training, programs to engage in immersive experiences and broader communities, and a team-based capstone senior design project that can have real-world applications and impact. I'll cover these elements in the next few slides. In your first year at Rutgers, in the School of Engineering, you will primarily take a common curriculum comprising introductory chemistry, math, physics, and engineering courses, in addition to writing requirements. There are a number of opportunities to learn about the different engineering majors, and students are given until midway through the spring semester to choose one. After choosing BME, early in your second year, you will be assigned a BME faculty advisor who can help you with course selection, career guidance, and identifying opportunities to gain immersive experience. In your second year, you continue completion of the math and physics requirements, as well as biology and engineering economics. You will also take your first BME courses. In this second year, you'll have the opportunity to apply to the BME Co-op program, which I will describe in a few slides. This is also the time to start looking for internships, research opportunities, and clinical shadowing opportunities, depending on your interests and plans. Your third year is focused on BME core requirements, including lecture-based classes in biotransport, biomechanics, biomaterials, biokinetics and thermodynamics, and numerical modeling, and lab-based classes in systems and devices and in measurements and analysis. You'll also be engaging, hopefully, in immersive experiences consistent with your career choices and plans, such as research, co-ops, and internships. At the end of the third year, you can apply for our combined degree programs, where you can earn a coursework-based Master's of Engineering or a research-based Master's of Science degree in an accelerated time frame. The BSMEng program can be easily completed in 5 total years. The BSMS program often requires more time because of the research component. There is no cost to apply to these programs, and GREs are not required. We currently have a 3.0 GPA cutoff, but students with lower than a 3.0 GPA can be considered depending on their performance in BME courses. The fourth or senior year is focused on electives and senior design. Many students choose to take electives that build strength in a subfield or a track, such as biomechanics and rehabilitation, tissue, cellular, and molecular bioengineering, and biomedical computing, imaging, and instrumentation. We also offer survey courses that demonstrate how biomedical engineering is applied in arenas such as global health, and professional development courses focused, for example, on innovation and entrepreneurship in biomedical engineering. The senior year is also focused on the team-based capstone design project, which I will introduce in a few slides. If you choose a combined degree, your 5th and 6th years will focus on graduate coursework, independent study for the MN students, and research and a thesis for the MS students before graduation. As an M1 major research university, we strongly encourage our students to get involved in research, and we have a number of programs to facilitate opportunities. The Aresti Research Program is a university-wide program that students can apply to beginning as early as their freshman year. The BME Honors Research Scholars Program is for students who are really interested in research and potentially interested in going to graduate school, and students apply to this between the summer of their junior and senior years. The James J. Slade Scholar Program for seniors is an honors thesis where students perform research throughout their senior year and write an honors thesis. And students can always pursue research independently by approaching faculty and graduate students to learn about different research opportunities and then receiving course credit for those opportunities. Research is a great way to develop problem-solving skills and understand the context of how core fundamentals can be applied to new and exciting problems in biomedical engineering. Our undergraduates have been co-authors on over 40 peer-reviewed journal publications from their research in the last 5 years and regularly present their work at regional and national conferences. We've recently launched the BME Co-op program for students who are interested in an immersive experience in the BME industry. This is primarily for students who have clear goals to enter the private sector. The BME Co-op program is designed to allow students to complete a 6-month co-op and still graduate in the typical 4 years by taking a subset of core courses over the summer before or after the junior year, depending on when the co-op experience is scheduled. Importantly, we also facilitate placement of students, mostly in New Jersey, in companies such as Johnson & Johnson, Bristol-Myers Squibb, Orthobond, Merck, the Musculoskeletal Transplant Foundation, and College and Matrix, but we've also placed students in out-of-state locations, including Celgene, which is now Bristol-Myers Squibb, in Seattle, and Smith & Nephew in Boston. For students who are interested in going to medical school, we have some programmatic elements. About 10 to 20% of our students pursue medical degrees or other health profession degrees. In our program, students who are interested in medical school can count the courses required for admission, such as organic chemistry, toward their BME requirements, so no extra classes should be needed. We also offer courses where students can interact with clinicians, such as our clinical immersion course, where students spend winter breaks shadowing practitioners, not to learn what a doctor does, but rather to identify need opportunities where a biomedical engineer can improve technology. The students convene after this shadowing experience and report on their new ideas. We've also catalyzed the formation of a student group called the Engineering Medicine Society, which has provided an important community for engineering students who are interested in applying to medical school. The BME curriculum culminates with the Capstone Senior Design course, where students work in teams on a year-long project. These can be student-driven initiatives, such as this group that worked with Professor Adam Gormley on a project that was awarded second prize and $50,000 towards research for a paper-based microfluidic diagnostic tool that can distinguish between a viral infection and a bacterial infection to limit the use of antibiotics and mitigate the rise of antibiotic-resistant bacteria. Projects can emanate from ongoing work in a faculty's laboratory, such as this project from Professor Martin Yarmish's lab. Senior design groups have contributed significantly to the design and development of a robot that automatically draws blood, like what a phlebotomist does at LabCorp. The robot uses different imaging approaches and machine vision to do hands-off blood draws and diagnostics. Students can also complete experience-driven projects, such as work at the Matheny Medical and Education Center, which is a hospital and school for severely disabled patients. Our students spend time at Matheny observing patients and practitioners, identifying needs, and then designing solutions. Example projects include modifications for wheelchairs and a self-sterilizing blanket. In this last project, our students observed that nurses spend a lot of time wiping down wheelchairs, which may not be the best use of their time. They designed a blanket that could be draped over a wheelchair to expose that chair to disinfecting UV light. Nurses are then free to care for patients while the chair is being disinfected. Experience-based project opportunities are expanding through partnerships with Operation Rebound, which supports veterans and first responders, and with individuals such as Eric Legrand, who was a Rutgers football player who became paralyzed from the neck down from an injury on the football field. While meeting with Eric to discuss his needs, our students observed that he struggled to hold and manipulate his stylus, which he uses to communicate on his smartphone. He holds the stylus in his mouth and slides it to the side of his mouth when he wants to talk. If he drops the stylus, he has to call for help. Our students took some measurements of Eric's range of motion with his head and neck, and measurements from his wheelchair, and then 3D printed a stylus holder that attaches to his wheelchair. It was probably a $5 part in terms of materials, and is about as uncomplicated as you can imagine, especially compared with the diagnostic tool from Dr. Gormley's lab and the robotic venipuncture device. But nevertheless, this was life-changing, and Eric and his mother both cried when they realized the impact that this simple design could have on his quality of life. So where does all of this leave you after 4 years? Well, we found that the rigorous training and problem solving at the interface of engineering, biology, and medicine has prepared our students for a variety of career options. As I mentioned, many of our students pursue medical degrees. Many of our students are captivated by research and pursue master's and doctoral degrees at top schools across the country. Students also enter the private sector with their bachelor's degrees, and we have students working in the pharma industry at companies like Janssen and Merck. We also have students working in the biotechnology sector at companies such as Regeneron and Celgene, which is now Bristol Myers Squibb. Students are working at consumer product companies like Johnson & Johnson and Colgate-Palmolive. And our students are working at medical device companies like Zimmer Biomet and Stryker. Finally, many of our students find jobs or join industries in areas that they probably didn't think they'd do when they started. For example, with our understanding of biomedical technology, the regulatory process, and quantitative modeling, many of our students go on to consult to help healthcare technology companies. Students also pursue law degrees with a focus on protecting intellectual property. Some of our students pursue careers in public health. We have students who pursue careers in banking or other financial industries, including this young woman who, only 5 years after earning her bachelor's degree, was named a vice president of life science banking at JP Morgan. We have students who have worked for virtual reality companies to improve training and preparation for surgery. One of our students used his understanding of biomedical transport and kinetics and thermodynamics and formed his own brewery. And finally, we have a student who is now a data engineer with the NBA. So what can you be as a Rutgers biomedical engineer? In the end, it's really anything that you want. I thank you for your attention. Here I've listed email information for a number of contacts in the department, and we'd all be happy to answer any questions that you have. Thank you.